Welcome back to Psych 101. Hi, I'm Desiree, your instructor for this series. In today's lesson, you'll learn exactly how psychologists turn ideas into actual science. We're going to break down the scientific method, explore the different tools psychologists use to study behavior, and uncover the ethical rules that keep research sound and safe. Essentially, we're learning to think like psychologists. So, how do we start thinking like a psychologist? It all begins with a real-world mystery. Last week, I told you a piece of pizza had vanished from the psychology lab refrigerator. I asked you to vote on the prime suspect. The votes are in, and you overwhelmingly pointed the finger at the janitor, with the gym bros coming in a close second. This is a perfect starting point. A psychologist doesn't just say, the janitor did it. They build a case, and the blueprint for that case is the scientific method. It's the essential framework that separates psychological science from mere opinion. Step 1, observation. We don't guess, we observe. The pizza is gone, the box is open. There are crumbs on the counter. We're not jumping to conclusions, we're just gathering raw data. We're simply asking, what is happening here? Step 2, ask a question. Our observation leads to a question. Not just who done it, but something more specific and, crucially, testable. A better question is, what factors in a shared workspace increase the likelihood of someone consuming communal food? Step 3, form a hypothesis. This is our educated guess, a specific, testable prediction. Based on your votes, we could form a hypothesis. But let's refine it. Instead of blaming a person, let's blame a condition. Here's a good one. If a person is experiencing high stress, then they are more likely to eat communal food. Notice that a good hypothesis must be falsifiable. That's a key academic term. It means we have to be able to prove it wrong. If we can't test for the possibility of it being false, it's not a scientific hypothesis. It's just a belief. Step 4, identify and define variables. To test our hypothesis, we need to be precise. We have two types of variables. The independent variable, IV, is the cause. It's the thing we manipulate. For example, our IV could be stress level. The dependent variable, DV, is the effect. It's the thing we measure. For example, our DV could be pizza consumption. But stress and pizza consumption are vague. In science, we need an operational definition, which is a clear, concrete, measurable definition of our variables. For example, we could operationally define high stress as scoring above a 15 on the perceived stress scale on the day of the experiment. And we could define pizza consumption as the disappearance of one or more slices from the box between 9 a.m. and 5 p.m. This precision is what makes it science. And now that we have a testable hypothesis, we need to pick the right tool for the job. Psychologists have a whole toolkit of research methods. Choosing the right one is critical. Let's see how a few would apply to our pizza case. First up, naturalistic observation. This is watching behavior in its natural environment. We could hide a camera by the fridge and just watch. The upside? You see raw, unfiltered behavior. The major downside? Reactivity. It's a huge concept in psychology. People act differently when they know they're being watched. If our pizza thief spots the camera, they might suddenly lose their appetite. So, what if we just ask people? This brings us to surveys and self-report. We could email everyone in the department a questionnaire. But surveys are plagued by social desirability bias. People tend to answer in ways that make them look good. The gym bro might say, I don't eat carbs, even if he does. Plus, memories are faulty. Our stressed out suspect might honestly not remember grabbing that slice. Okay, so what about a case study? This is a super deep dive into one individual. We could study our prime suspect for weeks, tracking their stress, sleep, and eating habits. We'd get incredibly rich, detailed information. But the fatal flaw of a case study is generalizability. What's true for this one person isn't necessarily true for everyone. This leads us to correlational research. Here, we measure two variables and see if they're related. For instance, we could track the department's average stress level each day and the number of missing pizza slices. If we find that on high-stress days, more pizza is eaten, we've found a positive correlation. If on low-stress days, more pizza is eaten, that would be a negative correlation. But, and tattoo this on your brain, it's the most important rule in introductory psychology. Correlation does not equal causation. Just because stress and pizza theft are related doesn't mean stress causes pizza theft. Maybe a third variable, like looming deadlines, is causing both the stress and the pizza eating. To prove cause and effect, we need the gold standard, the experiment. Let's design one. Our hypothesis is high stress causes pizza consumption. We'd create two groups through random assignment. One group is the experimental group and gets put into a high-stress situation. We tell them they have a surprise pop quiz in 10 minutes. The other group is the control group, and they get to relax. We tell them to watch cat videos. Then we present both groups with pizza and measure who eats more. Because we manipulated the independent variable, stress, and controlled for other factors, we can now make a causal claim. That's the power of the experiment. But before we start stressing out our colleagues, we have to ask a crucial question. Is our experiment ethical? Even for a pizza mystery, ethics are non-negotiable. Psychological research is governed by a strict code of conduct, often guided by principles from the Belmont Report and enforced by an institutional review board, IRB. First, we need informed consent. Participants must know they're in a study and willingly agree to participate. No secret cameras. Second, confidentiality. We have to protect the identities of our participants. We can't publish a paper titled Dr. Smith, the Pizza Thief. All data is anonymized. Third, protection from harm. We can't cause our participants significant physical or psychological distress. Is telling someone they have a pop quiz a form of psychological harm? An IRB would definitely want to discuss it. They ensure the potential benefits of the research outweigh the risks to participants. So, while our experiment is powerful, it might not even get approved. That's a key part of thinking like a psychologist, balancing the quest for knowledge with the responsibility to do no harm. All right, now it's time to test what you've learned. Get ready for the Brain Busters quiz. Question 1. Why is psychology considered a science? A. It focuses on feelings. B. It uses systematic research methods. C. It avoids experimentation. Correct answer? B. It uses systematic research methods. Question 2. Correlation does not equal causation means a relationship does not prove cause. A. True. B. False. Correct answer? A. True. Question 3. Why is informed consent important? A. It allows deception. B. It protects participants' rights. C. It speeds up research. Correct answer? B. It protects participants' rights. Nice job! Now let's wrap up everything we learned today. Today we learned that psychologists don't just guess. They build a case using the scientific method. They move from a simple observation to a testable question. They define their variables with precision, and they choose the right research tool for the job, all while following a strict ethical code. Now it's time for the homework-free zone. If you were designing the pizza study with full approval and no ethical constraints, which research method would you choose to find the culprit, and why? Share your answer in the comments below. I love reading your ideas. And if you want to be part of more polls and help shape future lessons, make sure you hit that subscribe button. In our next lesson, we're tackling one of psychology's biggest debates, nature versus nurture. You won't want to miss it. Thanks for being here. I'll see you in the next lesson.